Many anthropologists, linguists and primatologists have laid out for us the distinctives of human language. But the most significant feature is the emergent feature of our use of language that we make by speaking. And I don't just mean we perform speech acts, but that the entire state of our globe and the geological era we now live in, the Anthropocene, is a product of our coordinations in speech. Humans make by speaking. This presentation introduces the strange attractor that is common to all human making by speaking. This attractor has been researched, traced and documented by David Jones and Dylan Jones in studies that commenced in 1990. Systems that have many separate but interdependent parts and that respond to the environment are widespread in nature. We call them complex adaptive systems. Ants that build bridges or nests, or termites that build mounds are great examples. These insects get together and produce patterns we would never predict if we only looked at all the individual parts. Who would have thought you could get a 3-metre high air-conditioned termite mound if you just looked at a flying ant? To understand these complex systems, we start by thinking about dynamical systems, ones that show their behaviour to us over time. Think of a garden sprinkler. You could never predict where one drop would go, but you can rely on the pattern to choose where to put your sprinkler or what sprinkler to buy. We don't get understanding of these systems by analysing the details. What is ideal for deciding how to act in the world is that we sometimes understand the pattern and the simple rules that create it. In this case, we just step back and look for patterns. Sometimes seeing the pattern is sufficient for our purposes. In some cases, we can't see regularities in the pattern, but we do understand the simple rules that drive it. Climate change has just one simple rule. An increase in the Earth's average surface temperature is driving changes across the globe. But in its huge array of outworkings, its pattern is very hard to see. Sometimes, even when things do have very complex patterns, we can find simple rules that help us understand otherwise mystifying phenomena. In the case of the way birds flock, we have been able to imitate the behaviour in computers using 3 simple rules. Fly toward the centre gives cohesion, match the speed of others gives alignment, and avoid collisions, stay a little bit separate. In simple contexts like the garden sprinkler, we don't bother trying to understand the rules. But for really complex situations like weather prediction, understanding the rules and the pattern can make a huge difference to our lives. It turns out that something as complicated as the weather has at least one core pattern and some simple rules. The El Nino Southern Oscillator is a complex system. Modelling its pattern means governments can prepare for risks of famine in rural India or for tornado insurance premiums in the USA. What about complex and dynamic human systems? Many human activities have also been understood as complex adaptive systems. After all, they are made up of separate but interdependent parts that respond to the environment. People in cars are an example, where a great deal of modelling has been done to try and find the simple rules that could help design our way out of traffic jams. And there are many large systems that people are trying to understand as CAS. Roger Martin is talking about the US economy in these terms. Diane Larson-Freeman researches second language acquisition. Ralph Stacey looks at organisations, and Nancy Cook and colleagues study team coordination dynamics. Identifying those systems as having CAS features is one thing, but describing the attractor and/or identifying where the simple rules for a human activity might lie is itself a hugely complex task. And in human systems, so far only minor examples have been identified. The stadium wave that originated in Mexico is one we have learnt. Stand up when the person to your left stands up, sit down when the person to your left sits down. Humans also quite literally play with complexity. We make the simple rules first and then let the emergent patterns surprise and amuse us. The stadium wave and sports point to an important feature of human CAS. We can work with the rules and create new outcomes. Our capacity to cooperate in our industries, in our living together, and in our governance are issues about human activity that are a very long way from play. Would the discovery of an attractor for that cooperative activity lead to abilities to skill ourselves, to better diagnose and more wisely design our outcome-focused enterprises? In the everyday and in the profoundly important arenas of human activity where we are cooperating toward an outcome, no one has identified a universal attractor and no one has described the simple rules until now. Human cooperation toward outcomes is a complex adaptive system. Importantly, it turns out there is a discernible attractor that underlies this CAS. That is, the way humans cooperate toward outcomes has attractor features that are observable and measurable. As with the sprinkler illustration, a simple model will help get us started. The outcome-oriented conversations of a couple setting out to build their own home. They move through distinctive conversation phases. The early scoping conversations with a dream that roam widely and eventually settle on the things that matter most. The conversations with an architect, the person who can translate their block of land, their image of their rooms they will inhabit, and the materials they prefer into a single, well-resolved entity. And then the conversations of building where time, somehow it always seems to be a race before Christmas, becomes a key player. If those habitats of conversation get confused, we end up with the frustration of partners falling in love with building materials that are unsuited to their block or locale, or with significant disruptions to the building schedule as walls get moved halfway through the build, and so forth. At the level of our productive human interactions, ecosystemic themes emerge in the ways we talk and in the artifacts we use or create to support our talk. If we look at enough of these cooperative endeavours, the coordinations in conversation that lead to a new house or a new estate or to a cochlear implant or just to a picnic, we begin to see a pattern. We start to notice that there are ecosystems of conversational features that cluster according to where we are up to in any given knowledge-making process. When we're scoping out a new situation, features such as the breakdown that made us attend are well described, for example, by Heidegger. When we're generating hypotheses for change, for how to satisfy our want, features of ideation are prominent. The abduction of C.S. Peirce or the bisociation of Arthur Koestler come to mind. And when we're executing or implementing the solution we have characterised, all the themes of classic logic, linear inference, and in-out binaries become prominent. As well as looking at the dynamics that hang out together in ecosystems, we can look at the way some phenomena unfold along the pattern. Imagine some well-researched continua, such as the extensive work around orality and literacy by scholars like Ong and Ricoeur. any given phenomenon could be analysed in terms of its point on such a continuum. In fact, the pattern is widely noticed, but its rules are not understood. In his 2009 book about design thinking in business contexts, then Professor of Rotman School of Business, Roger Martin, described what he called a knowledge funnel, a three-phase movement advancing knowledge from mystery to heuristic to algorithm. The many other scholars who have theorised about this three-phase structure include Mary Ulbien and Bill McKelvey in Complexity Leadership Theory, Gollwitzer and Keller's Mindset Theory of Action Phases. Sarasvathy of Dardenne Institute details the features of entrepreneurial versus strategic and managerial thinking. Dockery and Lyra note that there are three domains of negotiation: social, dispute, and transactional. Shine distinguishes three cultures operating on different sets of assumptions: the executive, the engineering, and the operator. Look, Hobecker's work systems distinguish the domains of value systems, innovation, and added value. O'Keeffe's message design logics calls out that communication is not necessarily a uniform process and distinguishes three internally consistent and developmentally ordered stages in the acquisition of working knowledge. And on it goes. These parallels are not superficial. These very diverse researchers use the same concepts over and over again in building their constructs. So there is a pattern. Can it be modelled? And more importantly, can we characterise it in terms of simple rules? The answer is yes. Like the famous butterfly-shaped Lorentz attractor for weather, we can describe the recurrent pattern in the wild. And yes, like the simple rules for Boyd's, we can model the pattern in simulated contexts. To go on, we need to be aware that for those who work to intentionally diagnose and design large-scale social and enterprise systems, thinking of knowledge production as a question-answering activity is a prominent perspective. In other words, wherever teams are working together in large-scale knowledge production, the critical role of questions is often well understood. I'll pass over the many practitioners of questioning, such as Fran Peavy's strategic questioning, or Cooper Ryder's appreciative inquiry, or even Rudyard Kipling's Ode to Questions, and go straight to the big names. Albert Einstein: to raise new questions requires creative imagination and marks real advances in science. The historian Robin Collingwood says, we can understand a text only when we have understood the question to which it is an answer. In The End of Education, Neil Postman is emphatic. Questions, we might say, are the principal intellectual instruments available to human beings. And Margaret Archer was not speaking to undergraduates, but to world-leading economists when she said, the framing of a research question is often the most important element of a research project. Questions allow us to break open the black box of seemingly pre-given situations and predetermined narratives, says Lissac. And Snodgrass and Coyne say that the question posits a preliminary way of seeing. Yet what is really important is to not get caught up on questions as we learn them in grammar. The importance of the quotes and the practitioners is that they are describing the central function of questions in cooperative action and in life. Research by Lani Watson, a philosopher at the University of Edinburgh, reveals a question does not have to have a determinate answer. It does not need to be in the interrogative. It does not need to have a question mark, and it does not even need to be expressed in words, because our everyday understanding of questions is highly permissive. That is, we identify many more things as questions than we might have at first imagined, and certainly more than formal philosophical treatment of questions would allow. So the nature of knowledge development, of producing new social and material realities by talking together, is a process of question answering. To mix our metaphors with our movie memes, Gadamer makes a point that many other theorists and practitioners of knowledge development agree to. In Truth and Method, he says, "It is clear that the structure of the question is implicit in all experience. We cannot have experiences without asking questions. Recognizing that an object is different and not as we first thought, obviously presupposes the question whether it was this or that. From a logical point of view, the openness essential to all experience is precisely the openness of either this or that. It has the structure of a question. All new knowledge has the shape of a question. Is this, this or that? After a question arises, what follows takes on an inexorable and, if it is to succeed, almost invariable logic. The inexorable logic that follows the arising of a question takes this form. We clarify the question. We put the question in dialogue with a process of answering until the answer arises. We clarify the answer. We enact the answer. It is that logic that takes the shape of a strange attractor and forms the ecosystems of knowledge development that recur fractally at every level of human inquiry. So, there are three phase spaces in this strange attractor. The first phase is pre-question. The second phase is post-question and pre-answer. The third phase is post-answer. The relationship of the strange attractor to the simple rules is that the major phase transitions take place at the point at which we are content with our elucidation of the question and at the point at which we are content with our elucidation of the answer. The question answering complex makes it clear why the pattern can be fractal. Larger questions can be answered by smaller recursive sets of questions and answers. Why is this insight so powerful? Because the pattern is fractal, it provides a recursive frame of explanation of social forms, not just discursive forms. Each of these phases may be momentary and subconscious, or at scale they can have significant social, material and temporal dimensions. To give an example of each phase at scale, in the pre-question or arriving at the question phase, many First Nation cultures have social rituals for allowing the question to arise, such as circle talking that may go across days. These approaches are gaining currency as ways of proceeding in Euro-Western social improvement initiatives, which consult multiple stakeholders. In large-scale infrastructure projects worth billions, getting the question clear and stable results in requirements documentation. Design as a social technology has now swept enough Euro-Western enterprises for its character to be well understood as a set of conversations in which the problem and solution co-emerge. The transfer of specifications as contracts for the manufacture of specified deliverables, from estate housing to plastic cutlery to microchips, are clear instances of clarifying the answer. And every instance of the manufacturing processes that ensue are evidence for the phase of enacting a satisfaction. Because human inquiry is distinctively conducted in human language, knowledge development takes the form of making by speaking, and the attractor is revealed in conversational ecosystems. The conversational ecosystems are thus evidenced by recurring socio-material clusters of actions and artifacts. And because our human development, our growing up, takes place within this milieu, we develop a deep familiarity with this way of proceeding. Indeed, the attractor shapes our coordination and our cooperation toward outcomes. To respect the core identity of this social phenomenon, we refer to it as our conversational cognition. Wherever humans cooperate in purposeful pursuits, this attractor is visible at scale in their conduct and milestone artifacts at every level of recursion. The attractor gives rise to emergent phenomena we can observe in many arenas. And because the shape of the question very often arises because of a want, a lack or a desire, and answering the question lies in the satisfaction of the want, then the dynamical system that enacts the attractor has a socio-material gradient, a thickening of social interactions or of material interactions or both, a trajectory. And some of the most obvious components of the pattern lie in the gradients set up by the attractor. There's a connection between the pattern, the attractor, and the resultant ways of thinking, acting, leading, and organising. And that, in fact, is how the attractor was identified over the years of research into knowledge development processes. Some of these patterns can be described with a broad brush, such as this socio-technical gradient. The words are describing observable trends in social systems, not technical definitions. But recognising the attractor in the background could have a great deal of impact on how we define those terms. Another example. The pattern shows up in high-level features of our thinking. The pattern of hermeneutical, cyclical thought, making meaning out of our desires or sense of our needs. The pattern of iterative design, using abductive or dissociative modes to create novelty. The pattern of linear inferential thought, using logical and analytical methods to extrapolate and extend knowledge. Some of the emergent features have significant implications for ontology. Understanding what drives the distribution of social phenomena at different levels of organisation allows us to integrate what otherwise always seem to crop up as binaries and polarising choices. Boisseau and McKelvey drew on the phenomenon of power law distributed phenomena that is associated with this and created a single overarching framework to integrate the different ontological assumptions between the order-seeking regime of the modernists and the richness-seeking regime of the postmodernists. To conclude this necessarily high-level introduction, for this complex adaptive system, there is a discernible attractor. Human cooperation towards outcomes is a complex adaptive system, and it has an attractor. The attractor features are observable, noticeable, measurable. We are seeking research partners in different disciplinary domains whose work will be impacted by this discovery. We are looking for proactive engagement to research the implications of this attractor across many research and theory fields, and we would be delighted to talk to you about the possibilities for your research.